Hello lads, it's Boris again, and if you watch the introduction video, we will start by the theory of web services, and later we will implement some web services. So, I will explain it in a real production scenario. I want you to give you insight what you do in your job, okay? And why we use web services. Imagine we are staying here like a devs. Sorry for my drawings, but I'm not too good at it. I'm really not good actually. Okay, we are developers in company X. This is not the company of Elon Musk, this is just company X. Some name. Okay, we draw one line here. And here's company Y, company Y. Okay, and in our company we have a bunch of apps, web services. Here is web service 1, app 1, and this web service is written in Java language. Okay, we have a C Sharp application, C Sharp web service. Okay, those two communicate with each other, and we have plenty of this. We have 10, 20 applications. When I say web service, there is a contract to me to tell one application is a web service, but imagine when I tell you web service, this one Java application and Java Spring Boot application, for example. It's not a fancy thing. On company Y, imagine they have some application 10, web service 10, and it's written in C++. Their application raises x some variable to the power of 2. But this is just for example. Imagine this calculation here. This web service does something really important and really complicated. It's not we raising x to the power of 2, but it's something very complicated. But this is just an example. And in our company X, we don't have the time, or we are not working in the field of company Y, but we want this functionality here. And we are gonna pay the company Y a money to use this service. And they gonna tell us, okay, they have a documentation here for this service, how to use it. And your product owner, architect, or manager will give you this document. You make a communication with this company. You will be involved in this communication to communicate with them for implementation details, for example. And your job will be to extend this app to use this web service or microservice, or they can tell you, the architect can tell you, you build new application, new web service running on Node.js, written in ECMAScript, for example. You implement this and you implement this. I mean the connection with this web service. because we are paying for this and we want to use it right now. So you're either extending some implemented application or you're starting a new one. This is not important. And what is the interesting part here, which we are seeing? This is written in Java, this is written in C Sharp, this is written in C++, this is written in ECMAScript, running with Node.js server. So the communication is the magic here, because those languages are different, but who cares? The web service solves this problem. We are communicating over HTTP or HTTPS protocol. So let's break it down. Now, HTTP have a method. The method is the action we are performing on a resource. Okay, it can be get, post, patch, put, update, and etc. Okay, those are called CRUD operations. If you see CRUD, they mean this, and the abbreviation stands for create, read, update, delete, and in the context of HTTP methods, the get, for example, is for reading, the post is for creating, the patch put update, for example, is for update. There are differences between these two. Try to figure what is the difference. The D stands for delete. There is a delete HTTP method, etc. So we have a method. We have a headers, which gives us meta information about the actual data we will send over the HTTPS protocol. So we have headers, we have a body. The body contains the payload. And the payload is the actual information which will be transferred from here to here in the request and from here to here in the response. That's the payload. And you tell, but what about the headers, the method, and so on? This is the meta information for the data, for this data here. This is data. This is metadata. If you are not sure what metadata is, it's a data for the data. Imagine this data, we tell we will get this data, we will post this data. Some instructions and contract which this data applies by this metadata. This in a nutshell, explanation in a nutshell. You can read about metadata, okay? It's a bit tricky in the beginning, but you'll get used to it. So this is the HTTP protocol or the HTTPS protocol. Now we can have authorization header. For example, the first header for the data is content type. It can be application, JSON. JSON is JavaScript object notation. So it can be the content type. It can be application / XML. It can be many things. This here, the content type is header. Okay, it's in the header information. This is the header, and this is the value of the header. Okay, this is the value, and we tell this payload, this data will be in the type of application JSON. Okay, if we send XML here and it is defined content type of application JSON, it will be rejected by the server. So it should match this content type. There can be, and they are, authorization headers, for example, but let's keep it simple for now. There are authorization headers like auth tokens, JSON tokens, and base64 authentication, and so on. There are many types of security authentication that can be implemented in the HTTP protocol, so keep that in mind. We will get there, but we must dedicate a whole video for this. So in a nutshell, the HTTP is this. In a nutshell, very basic here. Okay, and we don't care. This is Java, this is C++. Okay, let's try to make a dry run here. But how you know? I want to go back to the real scenario. You're here and you're implementing endpoints in this application / some endpoint. Okay, some endpoint. Okay, and how you know which is this endpoint and what headers does it have, what method does it use, what body you should send in the request when you hit this application, what they expect here. They expect text, but in what format? In XML, in JSON, in something else. Alright, so in this document you have this information and you implement your business logic and request by the documentation. And if you have some doubts about some of the implementation, you communicate with these guys here at company Y, sorry, and they will tell you details what's happening. Okay, and so let's see what will happen if we send from Java to C++ a request. We hit this endpoint. If the body is in JSON, it will look something like this. In the endpoint, we will have path variables, query params, or body request. Those are three types of transferring the data. So I will break it down now. Okay, just a second. So this endpoint, some endpoint. Let's say this is the endpoint calc. So when the parameter x is here, okay, this is called a path variable. Okay, we will put the number here for the calculation here in the URL. This for now is URI. I will tell you the difference later. Now we can have /calc and we can have a query parameter. This here is denotes the operator for defining the parameter, and it will be x equals, for example, 5. You have this in the URL. Okay, so this is path variable, this is query parameter, and we have the third type, calc URL, and here we have a request body. If it's JSON, it will look like this. For example, x and the value 5. Okay, so imagine here sorry, here it's not equals, it's the question mark, the variable, and imagine the placeholder. Okay, this way, my bad. And you can concatenate this by end operator here, for example this, and you can have here again new operator. Okay, you can append more of this here. There are good practices for the different situations. We'll talk about this, but this in a nutshell, how you can send the data here, the paywall data in the URL. Okay, and imagine you are using this type of URL. It depends on the documentation. They will give us these options. They can tell you this is the way. Okay, they didn't implement those types of communication. You use this one. So you're sending a request. Calc, you put some number here. Okay, we put the number 5. Here goes the big calculation. And okay, we are putting 5 here by using this URL, and we are getting back 25. 6 by 6 is 25. Okay, so we use this application as software as a service. The same communication goes in our company, in our environment, the same way. This is called RESTful web service. RESTful web service is the same. It means that this server here don't use state. The server doesn't use state. So when you send requests, it's destroyed the data is destroyed, the request is destroyed, and the data, this data for example, when it comes here, is again stateless. This will be destroyed, but you have a database, you have, for example, Redis session, or for persistence you have, for session you can have Redis, for persistence you have, you can have SQL, and this number is already used in your logic, but here it is destroyed, is getting destroyed. This means it's stateless. The server does not provide you a state. This is the RESTful style. It's an architecture style. Someone tells it's a protocol. No, it's not a protocol. It's a architecture style, and there is a contract for some web service to be RESTful web service. We will see it in the next videos, but for now this is enough. So we will start implement this application, but we will implement it in Java. Okay. So I think this is enough for now, and later we will implement application 1, and we can write a documentation even. Okay, thank you guys.